The Lorentz transformation equations actually say that as the relative speed increases, distance shrinks from an observer who is at rest relative to the object that's traveling, and time slows down.
Keep watching to learn more.
Book 3 in the New Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today, we'll be examining the concept of non-locality. With me is physicist Dr. Edward Close, who is the author of Transcendental Physics. He is also co-author with Dr. Vernon Neppe of Reality Begins with Consciousness, and he has recently written a chapter published in a brand new anthology titled Is Consciousness Primary, edited by Gary Schwartz and Marjorie Woollacott. The title of that chapter is The Mathematical Unification of Time, Space, Matter, Energy, and Consciousness. Welcome, Ed.
Thank you, Jeff. It's a pleasure to be here, and I really appreciate your inviting me and making me feel so at home.
Well, I'm delighted to be with you here in Albuquerque. And let's talk about non-locality. I think many people have heard the term a lot. It's become a buzzword.
Yeah.
Many people use it interchangeably with what used to be known as clairvoyance, telepathy, psychic functioning. They like to talk about non-local consciousness, but to my understanding, the term actually originated within the context of theoretical physics.
Yes, that's true. And most mainstream physicists don't like it being applied to things like consciousness or especially to things like clairvoyance or that sort of thing, just because they don't really think those things exist many times.
Yeah.
But it's kind of interesting because to me it's what language does is enable us to communicate. But at the same time, you can almost take any given word and realize that it hides as much as it explains.
Mm-hmm.
And many words that come from science and filter out into the community of ordinary people is picked up and used in ways that make scientists shudder sometimes. An example would be even the speed of light is constant. That sounds so simple, and everybody thinks, oh, yeah, that means like a constant. If an airplane's flying across the country and it reaches a certain speed and it stays there, it travels at a constant speed. And, of course, that's not what it means at all.
Mm.
It's a much more deep and complex concept than that. And non-locality, I think, is the same sort of thing, and it originated, I believe, with the EPR paradox and the Copenhagen interpretation to explain that paradox.
I would have, in my recollection, the concept where I first encountered, I think, the concept of non-locality would have been, actually, I think I wrote about it in 1975 in my book, The Roots of Consciousness, in reference to Minkowski diagrams of the light cone.
Yes.
And showing that anything outside of the light cone, in other words, something so far away that it couldn't be accessible by through the speed of light in any given time frame, that would be, if there were communication with that realm, that would be non-local.
Yeah. I think the first time I came across it was reading a paper by John Bell, and he brought up the term. And like a lot of things in our language, English may be more than most, but in any language, gets interpreted through the lens of the consciousness, if you will, of the individual who uses the word. And in his case, he was talking about the difference between something that is a local phenomenon or a localized object or event, as opposed to one that is more widespread or happens over a distance. And it was brought up in reference to trying to explain quantum weirdness.
The idea of entanglement, that these connections seem to be instantaneous, faster than the speed of light. In other words, outside the light cone yet again. And that is counterintuitive to relativistic physicists. Now, I have heard people in parapsychology use the term, and what they seem to mean by it, when I push them on it, they say, oh, it has nothing to do with anything in physics. It simply means awareness of something non-local outside of your own brain, outside of your skull.
Yes.
If you can pick up information from the next room that you shouldn't know, that would be non-local.
Yeah. Well, I like to think of it this way. I read once, and I think it was a psychologist who wrote this and said, of course, we can only think about one thing at a time because we focus. And I have a problem with that statement.
So would my wife have a problem with that, who's always multitasking.
Yeah. And you can dispute that just by thinking, I can feel my feet in my shoes. I can feel the soles of my feet and the top of my head and the hair on my head at the same time. I can very vividly picture the Great Pyramid, for someplace that I've been, as if almost I were there. I can remember the smells and the scenery and everything, and at the same time know that I'm sitting here in this chair in Albuquerque, New Mexico. In a sense, that's a kind of a non-locality, so it's very understandable why people like to associate that term with consciousness, because the function of consciousness is to be aware, but focus means to draw distinctions and focus on some part of that awareness, but it doesn't mean you're totally unaware of something else that's going on at the same time. So we're capable of a lot more than we normally do, I believe. And so I don't have a problem with that because, as we've discussed before, but I need to say in this context, that I've actually had out-of-body experiences that have been verified by, after the experience, finding physical objects and things like that were viewed from that out-of-the-body position. And also in a book that you're familiar with, The Autobiography of a Yogi by Paramahansa Yogananda, he talks about his first, in this life, experience of cosmic consciousness when his guru struck him lightly over the heart and immediately had a global awareness. he could not only see everything around him without turning his head, he could see a cow passing on the other side of a wall, and he could see her just like he was seeing her with his physical eyes, but when the cow went past the gate, he could still see the cow and is aware of it. Mm-hmm. And people walking and so forth. This is hard for us to imagine because we train ourselves to focus. So most of our experience has to do with locality. Mm-hmm. So that's why non-locality is kind of hard to grasp.
Well, it seems to me that when it comes to an experience like that, you could call it cosmic consciousness, you could call it clairvoyance, you could say he had a moment of psychic insight, but parapsychologists in particular are very sensitive to the sociological impact of various words. And
sure.
Because a word like psychic often turns a certain segment of the population off, they associate the word psychic with fraud and chicanery of all sorts. So parapsychologists periodically are always looking for new words, like it's no longer clairvoyance, now it's remote viewing.
Yeah.
And it's mostly just a way to get past people's defenses.
Yeah, and that's understandable because it hasn't been that long that even psychology, not parapsychology, was considered a kind of a fringe, non-scientific idea. Mm-hmm. And so it's natural for people to try to convince other people that they know what they're doing.
Yeah. And if you have scientific sounding language that people are not immediately put off by, maybe that's helpful. I'm inclined to think otherwise. I'm inclined to think that some of the original terms, for better or worse, you might as well stick with them because sooner or later those objections that people have are going to come up anyway.
Yes, yeah. It's very definite that every word has many meanings. I think that's really true more in English than it is in most other purer languages, because English is basically a Germanic language that's had a lot of influx of Latin or Romance languages and Greek and Latin, so that it's a kind of a mixed up language, and words can mean kind of what you want them to mean, but sometimes you almost have to invent a new word. But when you do, then it's still going to be viewed by people through the lens of their particular understanding of what it evokes in their mind when they hear that word. And it's, I would argue that's probably, you could take almost any word and it would be different. If you have a room full of people, you'd have a room full of interpretations of that word.
Well, I'm inclined to think that the use of the term non-locality in physics, it may actually be very appropriate for describing consciousness. And let's explore in a deeper sense exactly what the physicists are getting at when they say non-locality. Because I suspect if you probe deeply enough, we would have a whole different picture of space and time altogether.
Yes. And that I make that connection too, because I think what John Bell was talking about, and what writers like Michael Talbot and good perceptive scientific writers are getting at, is things that we find in quantum experiments and so forth, like the reciprocity between two particles that seem to communicate over distance, like you mentioned. We have to call that something, and in classical physics, there just wasn't a word for it. But there was a word called local phenomena, something that happens only in one specific spot. So this seemed to be the opposite of that, or wasn't that. It was something else, so we call it non locality.
Mm-hmm.
But I think what physicists are getting at, and they get very upset if you, many of them do, if you relate it to consciousness, because they'll tell you it has nothing to do with it. It is simply to understand and explain some empirical phenomena that occur when you're dealing with quantum, at the quantum level,
mm-hmm.
with things like particles and waves.
Mm-hmm.
So it's, as you know, my research partner, Dr. Neppe, is very fond of neologisms.
Yes. Mm-hmm.
In effect, the English language is full of them because we're inventing them all the time. When I was in high school, certain words, they were not words. They weren't in the dictionary, and you weren't supposed to use them.
Mm-hmm.
Those same words now are in the dictionary, some of them, like ain't.
Right, the dictionary changes all the time.
Yes.
I used to, when I was a kid, people would say, ain't a word, because ain't in the dictionary.
Right, exactly. Yeah.
And I looked in the dictionary, and it was there.
Yeah, and it keeps being updated.
Yeah.
And non-locality is one of those words that originated in the scientific community to explain physical phenomena
mm-hmm.
that didn't seem to fit into the picture of something you could call mechanistic with a local cause and effect relationship.
Mm-hmm.
So, in a way, it's the first admission of the physicalist that there is something else going on that cannot necessarily be explained with a physical mechanism.
Mm-hmm. Well, now, we had a previous conversation talking about the constancy of the speed of light. And
yes.
we pointed out in that discussion that at the speed of light, time actually stops.
Yes.
So that a photon could travel from one end of the universe to the other, which we would measure as about 13.8 billion light years,
Yeah.
and no time would have passed at all.
Right.
If you're on the photon. If you're riding on the photon. So if you can travel a distance in no time, that would imply by the normal formulas of speed and measurement that no distance had actually been traversed.
Yes, and actually the equations of relativity bear that out, because what happens is that the transformation equations, the Lorentz transformation equations, actually say that as the relative speed increases, distance shrinks from an observer who is at rest relative to the object that's traveling, and time slows down. And so this is really the amazing revelation that Einstein made. The equations were there before, but nobody had looked into this as deeply as he had to understand that it actually meant that there was a change going on in physical measurement, which is usually thought of as very concrete and solid. That actually things like time and space, and this is what brought people like Michael Talbot and John Bell to say we're going to have to rethink how we explain and understand space and time.
And that seems pretty fundamental. And not only that, in one of our other discussions, you pointed out to me, I think it was Max Planck, the founder of quantum mechanics, who questioned whether matter even existed.
Yes. The famous quote is that as a man who spent his life doing the most hard-nosed type of science, studying matter, I can tell you this, there's no matter as such. And this, if you think of it in one way, this is kind of what we see when we start looking at matter. We find out that atoms are mostly empty space, or we think that it is. Comparatively, most of the volume of the atom is not taken up by the particles that we discover that are in there, like the electron and the proton and the neutron. So something has to explain this, and but that we have the intrinsic sort of or built-in idea that time and space are kind of a backdrop against which everything happens, and that was totally blown away by the theory of relativity. The old idea of a universal ether in which everything moved. They had to have that kind of concept at one point because every form of energy that we could measure had some sort of a medium through which it moved.
Yep.
Sound moves through air and so forth. But light travels billions of miles, hundreds and thousands of light years, through what is apparently, in terms of matter, empty space. There's no matter in a lot of that, and yet it somehow travels. So what is a medium? They thought, well, there has to be a universal medium. Well, Einstein said no. And that's one step forward in his little appendix to his book on relativity. He said space and time have no existence of their own. They only exist as measurements within a field of mass and energy. And of course, what we're doing in our model, the Neppe-Close model, is including consciousness in our model of reality, which we think it's time to do that, and that we think it needs to be done. Otherwise, science is sort of boxed in by not really being able to study the kind of phenomena that we're talking about, except in terms of statistical analysis to prove that it actually does exist. It actually does happen. But we need a theoretical framework within which that fits. And the current materialistic mainstream science doesn't have that. The framework is too small.
Well, one of the premises, I think, of science in general is that the universe is understandable. It's possible that we could understand it, that some people say it this way, we live in a rational universe. And yet, you and I have just described how, according to the theory of relativity, if I'm a person riding on a photon traveling across the universe 13.8 billion light years, I can do that instantly from my point of view. From the point of view of an observer, let's say on the Earth, it would have taken 13.8 billion years. So that to me seems to defy rationality. It seems completely paradoxical.
Yes, it does, because in our experience, we're not dealing with extremes very often. We're sort of in the middle.
Yeah. And
the velocities we deal with are very limited, very slow compared to the speed of light. The fastest jet on the planet doesn't even approach a small fraction of the speed of light.
But the experiments have been confirmed. We know that, let's say, on a rocket ship traveling, 30, 40,000 miles an hour, time actually does dilate.
Yes. Yeah, that's been verified several times, and verifies what Einstein was saying, that space and time are relative to the motion and the mass and the energy of the system within which it's observed. So the next step, it seems to me, is to bring in something called Gödel's incompleteness theorem. And this is another thing that I think eventually will get into common parlance, where people will talk about this as if they know what it is, just the way they do now about relativity and the speed of light being constant and
non-locality.
Non-locality, exactly. But it does explain a lot, because what he proved in, I think, 1933 was that in any consistent logical system, you can make meaningful statements or ask meaningful questions that cannot be answered, proved or disproved in terms of logic, within that system within which it was stated. Now, when that first happened, it was a shock to mathematicians in particular. David Hilbert, who was like the leading mathematician at the time, probably just about had a heart attack, because his whole focus was to develop an axiomatic system within which any hypothesis could be proved to be either true, false, or meaningless.
He developed the concept we know of as Hilbert space, the idea of a space with infinitely many dimensions.
Yes, and many people confuse our 9-dimensional model. They say, oh, well, then you're talking about Hilbert, you're creating Hilbert space. And that's not quite the case, because we're very specific about what we define as a dimension. In Hilbert's view, anything that could have a variable assigned to it and could be measured in any way could be a dimension in Hilbert space. In our conception, the only thing that in the physical world, in what most people consider the real world, or even the mental world, the only thing that can be called a dimension is something that has a variable of extent or extension in some way.
So we're looking at the difference between a mathematical dimension and a spatial dimension.
Yes. Yes. And but with one difference, our dimensions, when we go past the 3 dimensions of normal space that everybody kind of agrees on, and says, oh, we're all aware of 3 dimensions of height, width, and depth. When we go beyond those 3, the dimensions become much more subtle, more complex. And the first one is time, and that was introduced really by Hermann Minkowski, who you mentioned. Einstein at first, you may know this, at first he kind of rejected the idea, and he said that's unnecessary mathematical sophistication, and kind of rejected it. But in time, over a few years, a couple of years, I think, he came to realize that the only way he could really develop the field equation, the general field equation, would be to do it in that kind of a context of dimensionality. So what we believe, what we think we know anyway, meaning Dr. Neppe and myself, is that we're extending that kind of thinking, and other people started doing it, Klein and Kaluza. And,
if I recall correctly, Klein and Kaluza developed a 5-dimensional model, which proved, as far as I know, as a layperson, to be necessary in order to unify electricity and magnetism.
Yes, they were able to derive the Maxwell equations of electromagnetism from a 5-dimensional model rather elegantly. And then there was also a fellow, Finnish, I believe, named Nordstrom. Nordstrom was doing the same thing, a 5-dimensional model. He didn't get credit for it. He was doing this actually about the same time Einstein was introducing the theory of relativity. Nordstrom had already developed a 5-dimensional model, but it didn't get noticed because Finland was under Russia at the time, under the domination of Russia, and he wasn't allowed to publish in anything except Russian. But he finally got out and published it in Swedish, but it never got translated into English until much later, so he didn't get credit.
I see.
So there were several people working that way. And then mainstream science kind of got derailed from that, and it must have been kind of disconcerting to to Albert Einstein and Max Planck because they were great friends and they were working together, and they were believing that they would soon see quantum physics and relativity integrated into a common theory. And of course, Einstein brought up the whole idea that began to be called a theory of everything by saying, let's see if we can't come up with an equation that will include all of the known forces of nature.
In other words, if I understand what you're saying, there are four forces, gravity, electromagnetism, and the weak and strong nuclear forces. The theory of relativity accounts for gravity. Quantum mechanics accounts for the other three.
Right.
And unification would entail one model that could explain all four.
Yes. And, of course, being optimistic, Dr. Neppe and I, first of all, our model does that, in our opinion.
Yep.
And we feel that for that reason, it'll eventually be accepted. Right now, there's a lot of resistance to it because most of the people in physics and mainstream theoretical physics have been trained and brought up whether they realize it or not, where the metaphysical basis, and every logical system has a metaphysical basis, whether you've defined it or not. And their metaphysical basis is one of materialism, that the only real things are concrete things like matter and energy.
Yeah.
Even in spite of the fact that their most forward-looking research says that matter isn't what we think it is, and time and space are not what we think they are.
And I imagine if we look closely, we'd have trouble with energy as well.
Yes. And this is kind of reflected in the view of dark matter and dark energy, when a scientist being interviewed said, well, of course, it's some kind of matter and energy. We just don't know what kind. It's something we haven't encountered before. In my opinion, that's just reflects the box that individual thinks in. And back to the Gödel incompleteness theorem.
Yeah.
If you have, if you've shown that the model that we have, or the understanding that we have, the consistent logical explanation of some part of the universe, and we can and do come up with statements or questions that can't be answered within that, the first thought people had, David Hilbert himself, I think, thought, this is horrible, this is terrible, because it means we can't ever really answer that question.
Even if you have a scheme with infinitely many dimensions, it's still inadequate.
Still won't do it.
Yeah.
And actually, after the dust kind of died down in the theoretical math and physics community, a few began to realize that it wasn't the end of the world, and that, in fact, that very same statement, whatever it might be, could be proved in a more comprehensive logical system. And the only way you get a more comprehensive logical system, or an expanded system that is more comprehensive, is to go back and look at your a priori assumptions, the axioms upon which you build it. Now, this may be a little bit of a tangent, but I think sometimes that takes us in the wrong direction, because in looking at Euclid's geometry, one of the things they liked to do, mathematicians, was to say, well, the axiom that two parallel lines never meet, let's just say we change that and say that they do meet. Then we have a whole different system called non-Euclidean geometry.
Which has turned out to be very important.
Very important and useful in a descriptive way, but not in a explanatory way, in my opinion. Mm-hmm. In my opinion, it leads us to thinking of certain conceptual constructions as if they were as real as physical data. Yeah. And that's not always true. And within TDVP, the math that we use, which we call the calculus of dimensional distinctions, there actually turns out to be a way to prove or disprove whether something is both conceptual and existing in the physical world or not. And that is, I mention that because it's of extreme importance. When I first said this, and Vernon was talking with a mathematical physicist in England, he said that can't be right. There's no way you can prove or disprove whether a hypothesis is true or not just purely with mathematics. You have to have empirical evidence. The missing piece is that you develop your mathematics by tying it to empirical knowledge, and ours is tied to the electron.
Well, now, isn't it the case with regard to Euclidean geometry that Einstein's theory of relativity posits a non-Euclidean world in which space and time, but certainly space, is curved?
Yes. And in fact, this leads to the idea, and Einstein expressed this, that if you have a four-dimensional reality, the Minkowski reality with 3 dimensions of space and 1 of time, if you define a line, a straight line within a four-dimensional reality, and you follow that straight line as far as it will take you, at some point it'll bring you right back to the very exact point where you started. Not just in space, but in time as well.
I've heard people say, put it this way, that if you could look and see forever, you'd end up seeing the back of your own head.
Yeah. Yes. That was the idea. Uh-huh. Now, to stretch this out of the box a little further, if there are actually 9 dimensions, finite dimensions.
Mm-hmm. Which is postulated in your work with Dr. Neppe.
Yes.
TDVP.
Yes. And if the next 3 after the first 3 of space, and it turns out mathematically that this triadic thing is very important, mm-hmm. and it even fits with what we know about number theory. Mm-hmm. And because of quantum theory, we can tie it to integers. And so it gives us a whole new mathematics and a whole way of looking. And the second 3 dimensions are much more subtle and difficult to understand than the first 3. And we only see one point, and we only experience one point in that. And that's I would call it a quantum of time, which we always are in. And we postulate that it's on a line by remembering past events and projecting what we think will probably happen in the future. This defines a timeline. Well, if this line is different, my line is different than yours, and we can talk about the reasons for that, then in a sense we've moved into a kind of non-locality, mm-hmm. in that we've defined a plane of time with 2 different timelines and many more.
So we might say, for example, that your timeline and my timeline are at this moment intersecting on a plane because we're communicating together.
Yes, but mm-hmm. tomorrow they'll separate again, and in the past they've been separate. Mm-hmm.
And once they separate, you might be experiencing time very differently than I am.
Yes, mm-hmm. It's possible. And then the only way we could become aware of this, and this gets into something that I call dimensional extrapolation, is by being in a third dimension of that domain. Yeah. If we were, then we would be capable of some of the paranormal type phenomena
and now that's a real head scratcher, because we're so accustomed to thinking of time as linear and unidirectional.
Yes.
That to talk about, like go to 6 o'clock and make a right turn seems incomprehensible certainly in the English language.
Yeah. Well, John Wheeler is interesting in this respect, because he showed that actually, because of an action taken in the present, we change what we can say about what happened in the past. Mm-hmm. So this is really kind of mind-boggling, because it suggests that your past is not fixed in stone, mm-hmm. that actually by things being done in the present, we may actually change our past.
Well, there's a whole series of studies in parapsychology known as retrocognitive psychokinesis,
yes.
In which one researcher, Helmut Schmidt in particular, a physicist, attempted to demonstrate that that's exactly what can happen under certain circumstances.
Yes. Mm-hmm. Well, we talked about in an earlier conversation, we talked about the double slit Dirichlet choice experiment, and that actually demonstrates that we can change something at a point in time that actually changes what we can say about what happened in the past. And that's rather mind-blowing. But
totally mind-blowing. The double-slit delayed choice experiment that we discussed in another interview, I still have a hard time wrapping my mind around it.
Yeah, and we do, because in our normal everyday life, mm-hmm. we don't believe we're in that kind of a reality. It seems to be time seems to be very much something that is unidirectional and so forth. Now, if you go to the third set of these 9 dimensions, Dr. Neppe and I are talking about consciousness. Now, Dr.
Three
Neppe,
dimensions of consciousness.
Yes.
In other words, 3 dimensions of space, 3 mm-hmm. dimensions of time, 3 dimensions of consciousness.
Yes, that's the 9 dimensions of our model, mm-hmm. and those 9 finite dimensions, measurable in some way or another, actually are embedded within a transfinite reality. Which
would be like Hilbert space,
yes.
in a sense.
And then beyond that, you have infinity.
But you've said earlier that your dimensions are spatial. They are dimensions of extent.
Yes.
How do you apply that to consciousness?
Time. Well, let's take one step at a time. If you think of it in terms of time first, mm-hmm. there is extent in time. We really can think of it that way. Now, it is hard to think that the reality is that way, and that's what leads to the kind of things we've been talking about. But then if you move to a much more subtle, like time, the time domain is much more subtle than the space domain. Mm-hmm. And then the consciousness domain is even more, it's, maybe this is a exponential curve of complexity in that it's much more subtle and complex. So, what I would say is that we are non-local beings. Mm-hmm. To get back to the word we started with, we're non-local beings in the way we think and act and perceive, and even our awareness is non-local. And as we move into this, if we at this point in time, most people at least, and we're evolving beings, we're all changing all the time, hopefully in the right direction, in a more inclusive and more understanding and a greater awareness. But if we think of it in this way, then at this point in time, most of us at least, maybe neglecting a few strange people that seem to have abilities we don't understand. Most of us actually experience, in this context of the Neppe closed TDVP, experience 5 dimensions. Because a lot of people will say to us, well, we only experience 3. No, actually you experience 5, because you do experience time, albeit a quantum of that time, and you do experience consciousness, and it's a quantum of that consciousness. So each individual is like a quantum of consciousness. But that quantum is, as I say, it's more complex and subtle. It is expandable. And that's increasingly true as you start from 1 dimension all the way up to 9. Mm. So a person who has awareness, and there's another concept here that might help to illuminate this idea, and that is that dimensional domains are nested like the Russian dolls, so that theoretically, at least, if your awareness has been raised to a particular dimension, you are aware of all of the other dimensions below that, just like the average person today. Being aware of time enables him to look at space from the point of view of a point or a quantum in the time domain. So you're really, in effect, projecting yourself out of 3 dimensions in order to see the 3 dimensions. Mm-hmm. And if this continues on, then this speaks to the idea going beyond what we think of as physics, but the idea of cosmic consciousness, where a person eventually will evolve to the point where they're aware of all of these dimensions, and that person would be an extraordinary individual.
Well, when I think of consciousness in terms of dimensionality, the words that come to me would be heaven and hell, being the 2 extremes. In a sense of consciousness, and a range along that parameter.
In some ways, we experience both ends of this all the time. In normal life, we are limited to this little cage of the body. We're sort of imprisoned here because we identify with it. And identification and intent. Intent's becoming a popular word, too. Mm-hmm. Of our consciousness, of our little quantum of consciousness, identifies itself with this body and this mind and this spiritual understanding. My belief is, I call it a belief, as a scientist, I'd say a hypothesis. My hypothesis, which I believe is a reasonable one based on things that I can talk about, is that we're progressing in that way, and that if we arrive at a greater awareness of these nested domains, then that's the way we are progressing and expanding our awareness. And at that point, our awareness becomes very non-local as soon as we depart from 3, but really, definitely when we extrapolate ourselves beyond 4.
Mm-hmm. Well, from the perspective of what is often called cosmic consciousness, it's like everything, all time and all space exists in one moment and in one awareness.
Yes.
That would be non-local.
Yes, that would be very non-local, and that's what I think is the future of the human race, of consciousness. Our research shows that there's consciousness in everything, and it's developing, and it's spiraling upward toward that overall consciousness, awareness of reality.
Well, Dr. Edward Close, once again, a very enlightening, informative, and I have to say delightful conversation. Thank you so much for being with me.
Thank you. You ask great questions.
And thank you for being with us.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.